Welcome to Developing Graphics Frameworks with Python and OpenGL, Part 33, Cylinders, Prisms, Cones, and Pyramids. We recently created a Parametric Geometry class, which enables us to graph three-dimensional surfaces if we know the equations of the surface. In the previous video, we figured out the equation for a sphere and a related shape called an ellipsoid, and so we can now graph spheres in our framework. In this video, we're going to derive the equations for a cylinder, and we're also going to see how, with just a slight modification, we can get a lot more shapes that are related to cylinders. But to begin, we have to derive that parametric equation. The analysis is actually really similar to what we did when we thought about the equation of a sphere. The idea is take a cylinder, such as this, and we'll think about cross-sections. Remember, that means slices. So we're going to slice along the y-axis into little pancake shapes. And again, those are going to be circular in shape. You might wonder, can you get any other pancake shapes or slices or cross-section shapes other than circles? The answer is yes, we can, and we'll see some of those later in this video. But for a cylinder, our starting point for this discussion, the cross-sections are circles. And again, we always do cross-sections with respect to the y-axis. And we'll have the same starting point as we did for deriving the equations for a sphere. Since the cross-sections are those of a circle, we'll start with the parametric equations of a circle of radius r. And those equations are z equals r times cosine u, and x equals r times sine u. And to do a full revolution around the circle, u must go from 0 to 2 pi. Now, deriving the equations of a cylinder are much easier because the size of those cross-sections do not change as you go above or below on the y-axis. Right? You have constant radius cross-sections. So r is just going to be some constant that we specify. Now, what about the y-values, though? How can we calculate the y-values? Well, the y-values, it depends on the height we want to have for the cylinder. So let's say we have a height h. Let's also assume we want the center of the cylinder to be at the origin. In that case, one way to parameterize that range of values is saying that v will go from 0 to 1, and then using this equation for y equals the height h times v minus 1/2. That means when v equals 0, y will equal negative 1/2 h. So that'll give us this point down here. When v equals 1, y will be positive 1/2 h. That'll give us that point up here. And the distance between those points is the height h that we'd like to calculate. So that's actually it for the equations of a cylinder. We can specify any height and radius that we wish, and those are the equations for x and y and z. Now, once we know the equation of a cylinder, it turns out we can generate the equations of lots of other cylinder-like shapes or cylindrical shapes. For example, we've been thinking of a cylinder as having circular cross-sections, but you might remember when we talked about polygons that we can never have a true circle in computer graphics. What we have is a polygon with so many sides, it's indistinguishable from a circle. But you might wonder, well, what happens if we do not use a large number of sides in our polygons? Well, then they legitimately look like polygons and not like circles. So if you follow the same argument as we did to generate the equations of a cylinder, but use a small number of sides, you're going to get a shape like one of these. where the cross sections are polygons. So for instance here, the cross sections are triangles. In the middle graph, the cross sections are hexagons. And in this graph on the right, the cross sections are octagons. And these kinds of shapes are called prisms. So we have a triangular prism, a hexagonal prism, and an octagonal prism. And it turns out that we don't really need different equations for these. We just need to use a different resolution when we go around in the u direction. We choose a smaller number of points on the circumference of that circle, and then we can generate this entire family of solid shapes. Now, in addition, we can go from a cylinder to a cone shape. A cone is like a cylinder, and it's also actually like a sphere. The cross sections, again, are circles, but in this case, the radius of the circle is at its largest at the bottom and then decreases linearly and becomes 0 up at the top here. So we can actually create a different kind of cross section, or a different radius cross section. Instead of using a constant value for r, the radius, we'll use a function for r. Now, it won't be a sine or cosine function like when we were talking about the equations of a sphere. It'll be a much simpler function to create the shape, as we'll soon see. And just like you can turn a cylinder into a prism by using polygon cross sections, you can turn a cone into a pyramid shape if you use low resolution circles, or if you use polygons as cross sections. So if we can come up with the equation of a cone, we can change the number of sides, or the resolution along u, to get pyramid shapes. And so we're going to be able to generate all three of these shapes, or all four of these shapes really: cylinders, prisms, cones, and pyramids. Our approach is going to be, we'll create the most general version of all of these, one which has a variable radius on the top and radius on the bottom, so we can specify those separately. We'll call that class a cylindrical geometry, and then we'll extend that class to get each of these four different shapes. So to get started, let's go ahead and open up our development environment, Sublime Text, and we're going to create a new file in the geometry folder. Let's save this one as cylindrical geometry.py. All right. Now, the code for this one, again, the most important thing is the equations, the parametric equations for the surface. But before we do that, we need to go ahead and, well, import some things. So from geometry.parametric geometry, we'll import the parametric geometry class. That's what we'll be extending. And again, we're going to use a little bit of trigonometry here. So from the math package, let's import sine, cosine, and pi. And pi. Now let's make the class cylindrical geometry. It extends the parametric geometry class. Let us define the constructor. Let's see, self, and we'll fill in some parameters in a moment. Let's start seeing what that function is going to look like. The parametric function which defines the surface, I like to call that S of u comma v, is going to return, well, first, we said the equations are going to be sine u, and then whatever we want the height to be, times, oh, and I should say radius here. Radius times sine u, height times v minus 0.5. That was the y coordinate. And the z coordinate would be the radius times cosine u. And with that function in place, we could then call super.init and put in the different parameters, 0 to 2 pi. Then we need however many radius segments we need. I'll just put in a placeholder for now. For the v, we're going to use 0 to 1. And again, however many height segments we want. And the function. Right, and this would create some kind of a cylinder shape if we had a radius and a height. But remember, we want to create shapes like cones and pyramids from this class. So we want different values for the top radius and the bottom radius. And then, depending on the value of v, how far along we are on the y-axis, for large values of v, we want the top radius. For small values of v, we want the bottom radius. So we're doing like a weighted average of a top and bottom radius, and we've seen a calculation like that before. So let's introduce some parameters. Let's say radius top. Let's default that to 1. Radius bottom, let's default that to 1. And height, let's make that 1 as well. Now this coefficient, height, is perfectly fine. We don't need to change that at all. But we need to replace radius with all the kind of average of the top and bottom radius. Let me go ahead and enter this equation here. Then we'll talk about what that's doing. But you might remember it from discussions about things like interpolating vertex colors. It's the same kind of calculation. All right, and I want the same expression down here. So the idea is the values of v range from 0 to 1. When we're at 0, that's the bottom of our shape, right? And if we put v equals 0, that would cancel out radius top and leave us with radius bottom. So at the bottom of our shape, we have the correct radius being applied in x and z. When when v equals 1, that means we're at the top of our shape, top of the y-axis. V equals 1, if we plug that in here, we'll get the radius top plus 0 times radius bottom, leaving us with just radius top. So when v equals 1, again, we have the correct radius, whatever the radius of the top is going to be. And in between those values, it'll calculate a weighted average of radius top and radius bottom. Right. The other information we need, we do want to be able to change the number of radial segments, right? We want a small number of segments around the circumference of the circle if we want to create a prism shape or a pyramid shape. So I'll call this radial segments, and I'll call this bottom one height segments. And we'll actually assign these better names when we extend this class in a moment. All right, and that's what we need for a cylinder shape. Now, or a cylindrical shape. Now we're going to go ahead and create some extensions of this class. We're going to create actually 4 extensions pretty quickly. So first, let's add a new file to the geometry class, geometry folder. We'll save this as CylindrGeometry.py. And in this class, we need to import cylindrical geometry. So from geometry.cylindricalgeometry, import cylindrical geometry. Oh, I need to make sure that doesn't go lowercase. Let's say class cylinder geometry. It extends cylindrical geometry. Now, what are the parameters for a cylinder? Well, a cylinder just has one radius, right? It's the same at the top and bottom. Has a height. It's going to have some number of radial segments. We usually want that to be a large number because we want them to look like circles. We'll call that 32. Height segments, really doesn't change the appearance of the cylinder to use more or less height segments, so we can keep that number small. And that'll be our init. And then super init. All right, let's give this the parameters. The top and bottom radius are first, and those are both equal to whatever this one radius value is, followed by the height, followed by those two segments, the radial segments and the height segments. All right, we'll save that class. Let's give this a test really quick. Let's head over and in our root folder, let's make a new file. Let's save this one as test33.py. As always, we'll go over to our template class, select all the code, copy it and paste it in here. And then say from geometry.cylinderGeometry, import cylinder geometry. As always, I just need to change the object which is being rendered. Let's make that a cylinder geometry. And let's build this. Hopefully we'll see the side of a cylinder. Oh, well, it's not good. Takes 1 to 4 arguments, but 6 were given. Did I give it the wrong number of arguments? Let's see. Oh, I at no point in cylindrical geometry, I forgot to include these two. I should add those in. So let's say radial segments. Let's say that's 32 by default, and height segments. And let's make that 4 by default. All right, so in cylindrical geometry, we just needed to include those other two parameters. Okay, let's save that class, go back to test33, and try building that again. Hey, we've got the side of a cylinder. It's a little bit curved there. Cool. Okay, let's try some of these other classes. Okay, we did cylinder geometry. Let's maybe do prisms next. It's going to be a lot like cylinder geometry. So in the geometry folder, let's make a new file, save it as PrismGeometry.py. Now to be efficient, I'm going to actually copy the code from cylinder geometry and copy that into prism geometry. I'm going to change the name of the class to prism geometry. And what do I want to change here? We can keep radius and height, that makes sense. But when I'm thinking about a prism, I usually don't think of the word radial segments. I think of how many sides those polygon cross sections have. So I'm actually just going to change the name of this parameter to sides, and maybe I'll give it a smaller value. Maybe I'll make it something like 6. And let's rename that as sides. It's just a little bit easier to use with some better names. So let's go ahead and that's saved. Let's head back over to our test class. All right, I need to import that new class from geometry.prismGeometry, import prism geometry. And then down here, change the name of the class that I'm importing. Change the name of the class that I'm creating an instance of. Make a prism geometry here. Let's build this, see what we get. Hey, I mean, we can't really get a very good perspective on this. I guess we could rotate it. Let's make this thing rotate so we can see all those sides. So back in the test class, let's say self.mesh.rotate y by some random number, that random number, and let's try running that again. Oh, self.mesh.rotate y. What don't we like here? Let's see. Inconsistent use of tabs and spaces. Oh, I hate it when that happens. Oh, let's see. So somewhere here, I'm using tabs instead of spaces. Must have happened when I copied and pasted. Fortunately, there's a nice, easy way to fix this with Sublime Text. So let's see. So for spaces, it's in one of these. Let's see. Edit. Which one is this? Comment. Case. Nope. Selection. Nope. Find. View. Go to Tools. Project. Not under File, is it? No. Where is this? I think I just missed it. It's in Indentation. So I can convert indentation to spaces just to be consistent. And now when I highlight things, those little dots are telling me that I'm actually using spaces this time. It's very strange. I wonder why that happened. All right, save and build that again. There we go. Now we get a much better sense of the fact that that's a hexagon. Excellent. We have two more classes to make. So let's go back to the geometry and create a new file. Let's save this one as ConeGeometry.py. And let's see. I want to just make my life easier. I'm going to start with cylinder geometry code. I'm going to copy that into the cone geometry file. I'm going to change the name of the class to cone geometry. Now really, the big difference here is the top radius of a cone is 0. I'll still let the user set the radius, but that will really only apply to the bottom radius. The top radius is forced to be 0. All right, that's it. Let's save, go back to our test case, our test application from geometry.coneGeometry, import coneGeometry. Then we'll change the type of geometry we're setting up to a cone geometry. Let's build that. Hopefully you'll see a spinning cone. Yep, that is certainly a cone. Very nice. Okay, last change we're going to make is let's add a pyramid geometry. So again, in the geometry class, we'll create a new file. We'll save this one as PyramidGeometry.py. In this case, I'm actually going to copy the code from cone geometry. And so I copied that into pyramid geometry, changing the name of the class to pyramid. Right? The only difference is I want to use a different value or different name here for one of these parameters. Right, again, just like with prisms, when I think of pyramids, I don't think of radial segments. I think how many sides does the base have? So I'm just changing the name of that parameter so it's a little bit more readable. Again, the radius at the top is 0, and radius will correspond to the radius at the bottom of the shape. That's pyramid geometry. Let's save that class. Let's go back to our test case. Let us import pyramid geometry. And then, once we have that import statement, let's make a pyramid geometry. Save and build. See if we see a spinning pyramid. Hey, sure enough we do. So, again, a little bit of math. In this case, got us 4 new families of shapes. All right, that's looking really good. All right, I think that's a good amount of code for this video. One thing which might be interesting to you is what if you want to create some kind of a geometric shape that we haven't covered? Or we haven't talked about materials in a while. What if you want to create a material which doesn't look like this? In the next video, we're going to talk about how you can extend the geometry and material classes in an application to create all kinds of cool, customized shapes and coloring schemes. But we'll save that one for the next video. Thanks for watching.